My name is Nguyen and welcome to our webinar series. I would like to thank you all for attending this event. Today is the first of 5. So this is a 5-part series and we're going to predominantly be focusing on Studio RM Pro. We've muted the lines to clear the background noise, and if you have any questions, please submit them in the chat. We'll answer them afterwards. So this is our first session. We're going to go through the 5-week overview presentation so you know what you're in for if you do decide to attend the next fall, and a little bit of background. I would like to thank our North American counterparts, so the guys up in Canada. They actually did all the hard work in creating this webinar series and content, which makes my life easier. So we're effectively replicating the same thing, but with a true blue Aussie accent. So we'll get started with some of the intros. Now, we're calling this session, this 5-part webinar, about Studio RM Pro. So what is Studio RM Pro? So for those who are not familiar with our portfolio, this image effectively shows you all the current software packages that Studio, like Datamine, owns and support effectively. So we have something for every part of the mining cycle, from exploration, production, reconciliation, engineering, environmental, and even lab logistics. The bundle that we're calling Studio RM Pro is this bundle here. So Studio RM, a Status Neo, and Supervisor. So when you purchase this bundle, all the software packages can be used independently of each other, and you effectively have the most power and solutions for your resource estimation chain once you have these 3 things under the Datamine umbrella. We will be using these 3 products throughout the series so that you get a little preview of what they can do for you if you choose to utilize them. Now, just a little bit of background. Studio RM has always been part of the Datamine family. It's been there since its inception. Supervisor was added during the acquisition of Snowden Ontario, hence we now have a consulting side of Datamine, and a Status Neo was acquired via GeoVariance. We used to be competitors, but now we're all under the same umbrella. This means for you, you can now utilize the best components of each software to create the best product for your operation. The software in this bundle, since its acquisitions, a lot of our developers have made sure that the files, the projects, the workflow interact nicely and integrate smoothly with each other. So when you buy the bundle, you should be able to move your data and your workflow easily between the 3. So the 5-part webinar, these are the things that we will be doing. So we're going to go through the estimation workflow using the best tools that Studio RM Pro have to offer. So week 1, so this week, we're going to be doing data prep and geological modeling, and that's going to be in Studio RM. Week 2, next week, we're going to be doing our EDA, or our exploratory data analysis, in Supervisor. Week 3, we'll come back to Studio RM for block modeling and grade estimation. Week 4 for validation, we'll be sitting in Studio RM and Supervisor together to do the validations. And then in week 5, we then move into a Status Neo to run conditional simulations, because that's what a Status Neo is most well known for. This is the resource estimation workflow that we're going to be going through here. The dark items are the things that we will be covering for today. So we'll be doing our drill hole input and desurveying, our geological modeling, and compositing by domain. The end goal for today is to have our wireframes and drill hole files that we have coded with our domain, and then have them composited so they're ready for us to use next week to do our EDA in Supervisor. A couple of highlights, because we have recently released Studio RM 2.0, so there are some big feature releases. One of them is our new drill hole importer. So this can be found in our sample analysis drill hole tool. This component has been released in our most latest version. This tool allows us to obviously import our tables into Datamine, and part of the tool itself, it lets you validate and desurvey. Main points we want to highlight is that you can do a relatively stable OBCD link through here. So if you're using Acquire or you're using Fusion, you can hook up to it. The validations, this interface is set up so that you can build your own validations. It will pick up minor, like your typical issues and offer you quick fixes. You can obviously intervene and put in your own rules if you prefer. One of the key features that we do want to highlight is that it has the capacity for scenario setup. So what that effectively means if you're on site in a production group is that if you guys are have just recently got Studio RM 2.0 and you're using the new drill hole importer, one person can set up the drill hole importer and actually give the scenario to the rest of the team. So they don't have to go through and hook up everything. They just need to import the scenario, which is quite useful. With our implicit wireframing, Studio RM has 5 different implicit modeling tools. The focus today will be the vein tool here. So this is actually the best tool that we have for making all zones, so solids. We're going to be assigning domains to our drill holes to prep the data for implicit modeling, which is typical for this type of process. Something to note, we do want to highlight this because it's just new, is that we have a brand new fault modeling tool, which is where you can generate faults from strings and you can utilize them in the contact surface and veins tools. So the contact surface and veins tools can now honor scissor faults. So these tools have always been able to honor faults, but now if you design a fault that does not cut through the wireframe completely, it will honor that displacement, which is pretty cool. In regards to our compositing, once we have our drill hole data coded by domain and our all wireframes, we'll be ready to composite. So we'll be breaking our data into variable lengths to a homogenized length. So effectively our raw data to our composite data. We actually do have a multiple of composite tools. I'm going to go through one just for fun because it's pretty interesting. Composite with ore and waste. It's got nothing to do with the resource estimation chain, but could be a very useful tool to help you figure out your ore mineralization if you've got a big deposit. If you're in an open pit, we have composite over benches as well. So if you need to composite over a vertical bench, this might be more important. And obviously the traditional tool that we do use is just to composite down the drill hole. So that's what we will be doing for this session. I'll kick off with the demo. So just hang on tight while I just get rid of the PowerPoint presentation and hopefully everyone can see my screen. All right, so first thing I'm going to do is I'm going to import our drill hole file. So in sample analysis, I'm going to go to drill holes, this guy here. This little widget will pop up. So you can see that I've already imported 3 of the 4 files that I want to suck in. In my case, I haven't set it up to a database. I'm just throwing in CSVs. So if I want to import a new CSV, you can hit add tables and navigate to the folder to grab it in. But the interface is also clever enough that if you just simply click and drag the file into the interface, it will pick it up and field match accordingly. So everything I have in here is matched up perfectly. So borehole ID to borehole ID. The only thing I'm going to change is my geology that I've just pulled in because I'm not interested in these things. I'm just interested in the top 4. Once these have been mapped, we're going to go over to validate. I'm just going to click this validation tool. Oh, yes. And you can see that I've got a couple of issues regarding my survey data and also my assays. So I'll resolve the survey first. So I've got a whole bunch where it's saying that I've got large dip or azimuth curvature. This is more so to do with the function that this particular data set has long holes and they deviate. And so the rules that are currently being used are probably a bit too strict. So it's flagging issues at 10 degrees every per 10 meters. So I'm going to just change this so it's a little bit more suitable for the data set. I'm going to change that to 20. Yep, we do want that to change. So all those issues are gone for now. The other issues I have for my survey is that for these holes, I do not have a color survey. I've been offered a quick fix where it will insert a new record on 0 from the first valid drill hole record that it finds for that hole. So I'm actually going to use all those, utilize them, because that's not really an issue for us right now. Oh, it's a little bit laggy, isn't it? See how we go. Cool. Once I've chosen those quick fixes, I'm just going to hit commit. So now my survey issues have been resolved. I'm going to head over to assay, and I've got 3 problems. Got no downhole records for pan 115, not so much of concern at this point, but I do have duplicates for pan 101. I'm just going to untick the one that I don't want. So obviously that's a kind of input CSV issue. And I've got another issue here where I've got an overlap. So I've got a record of 41.5. And the next one is 41. So obviously I would go back to the drill hole data, look at the pictures, look at the entries and see what is it actually meant to be. And let's say I did that due diligence and I decided it's just a typo, and really it's just 41. So I'm going to type 41 into the screen, and that should be resolved. Cool. So I've resolved and committed all my issues. The nice thing about this is that we could actually export our validation problem. So if I click export and save the validations, and I've done one for us already, I'll just open it up for us. You can export your validation, and you can probably send this off to your database geologists and get them to actually fix the issues in the main database itself. So this is a nice little tool to have at hand. I'm not going to save this. I'm going to minimize that. And the other thing I'm going to talk about, so I've run through, set up the whole entire drill hole importer, and I want to give this to someone else. Obviously, I don't want them to do the same thing that I have done. So what you can do is you can create a new scenario, rename it accordingly. And what you can do is you can export. So when you export, you can export it out. I've already exported here, and you send this to people on your team. So if you sent this to someone and you want them to replicate what you've done, all they have to do is open the drill hole importer, and all they need to do is import the scenario, and then they can run the scenario. Another thing I just want to point out here is that to connect to the OBCD link or a database, it's this add connection. So we can connect to Acquire and Fusion. We own Acquire and we own Fusion, so they speak really well to each other. All right, so I'm going to head over to DeSurvey. Once I'm in DeSurvey, I've got some DeSurvey options. These DeSurvey options are the same as Holes 3D. So if you're using Holes 3D, you can actually just flip over to this if you want to. I'm going to accept this for what it is. I'm going to click Generate Drill Holes. And as you can see, it's running in the background. And what it should do for us in the end, once it's finally done and dusted, taking its some time, working hard there. Ooh, working very hard there in the background. Working mega hard. Once the file has been created, we should see in the background that's been generated there, which is pretty wicked. And it's also giving us a small drill hole summary of what is in that data set. So the number of drill holes, the total lengths, and it does a quick basic statistics on the grade that is in the data set itself. So that's done. So that's effectively our drill hole importer. So that's the one that's created here. Here's one I created earlier. with a nice template applied to it. So once we've imported our drill hole database, we're going to go and generate some wireframes using our implicit modeling tools. So a little bit of background about this particular deposit. So this has effectively three kind of main zones. There's Shear B, Shear A, and the intrusion. Shear B and the intrusion are good as they are, but the thing about Shear A is that it's quite a wide ore body, but not everything in Shear A is mineralized. So there's actually some areas where it's not mineralized as well, just so that we can have a quick look at what's going on. Oh, this is really struggling, isn't it, guys? Oh, well, we'll just be patient and hopefully it will run the way that we want it to run. So I've just applied a template where we can see our copper and AG grades. And you can see in through the Shear A, there are parts of it that are highly mineralized and parts of it that are not so mineralized. And I just want to constrain Shear A a little bit more. Let's say we've done the numbers and there's a binomial distribution and we want to knock out samples that shouldn't be in this ore zone. I'm just going to just reset the template for us. Back to our geology. So we'll declutter the screen. So what I'm going to do is I'm going to kind of use a batch fix. Is I'm going to use that interesting tool that I was talking about before, the composite oil and waste. So this composite tool lives in sample analysis in Composite, and it is called Composite with ore and waste. And I'm just going to hit restore here so that we can see what's getting run. So grade across length. I am going to go to the fields tab and I'm going to predominantly focus on copper. You can only choose one. So if you wanted to, you could probably use a copper equivalent, or if you're working in a polymetallic deposit, you could use a NSR, so a net melt return if you wanted to, whatever works best for you. Over in the parameters, this is where all the magic happens. We're going to set a series of parameters where the software will then make an assessment of what is ore and waste in this drill hole file. So the parameters I'm going to use is 1% for copper. I want the intervals to be flagged at least 3 meters. It can't contain more than 10 meters of internal waste. At least 90% of the assays, 90% has to be assayed. And I'm going to be aggressive. So I'm going to make longer composites of lower grade because this is a fairly thick deposit. I'm going to click OK. It's going to overwrite some files, that's fine. And what should happen is that I will generate a composite file where it will flag the intervals as either zeros or ones. So 1 is for ore based on the parameters that I've given, and 0 is for waste. That is effectively this data set here. So that's CompDH. And if I just quickly go show you what it looks like in the back end. So when I ran CompDH, Composite with ore and waste rules, it created a new field called OW code, and it's coded 1s and 0s. And I've displayed that file as 1s and 0s on the screen. So you can see that I have what's been considered mineralization and what has not been considered mineralization. I am going to quickly just filter this data set to see what my data looks like in just my shear zone. So I'm just going to use quick filter. In quick filter, I am going to hit apply now because I only want to see my samples in Shear. So you can see, oh, let me just get rid of sandstone because I'm not interested in that. But you can see in Shear A, so what has been classified as the kind of global zone, I have mineralized and non-mineralized samples. I'm going to filter this even more so that I only see the composites that have been classified as ore. I'm just going to go to format, just going to use the drill hole filtering tool. When that decides to load anytime. And I'm just going to use a rule where when the code equals 1 and geology equals Shear A, only recall the samples that are there. So we can see that in Shear A, the original wireframe that I had, and if I can get back to sheets, hopefully this is not lagging for you guys as much as it's lagging for me. Let's have a look at Shear A. So in through here, I've got samples, some of them, so that's what is sitting in Shear A. So I'm going to rebuild Shear A, and I'm going to build a new domain, and I'm just going to call it domain 1. And I will build a wireframe from these samples. So before I can do that, the drill hole file that I'm going to be working on, so Pandora or waste, I need to prep that. So I need to build a new field that I can code into. So I'm just going to right click on Pandora or waste, and I'm just going to go and add column. In through here, I'm going to create a new column called domain, so I can flag into that. I'm going to go OK. And a good motto is save early and save often. So I'm just going to quickly save this drill hole file. Once I've saved that, I'm going to now go to the implicit ribbon, and I'm going to use the assign tool. Once it loads, it's picked up the drill hole that has been loaded into the screen. I'm going to choose domain. Right now there is nothing, everything is absent. So I'm going to create a new domain. And I'm going to call it domain 1 when it finally decides to set itself up. Oh my, ooh, a bit trigger happy I have been. So let's say I want to code everything into domain 1. I'm just going to turn that pink so that I've got a bigger contrast. And let's say I want all the samples to be assigned to domain 1. So I'm going to assign them, say these files. I'm just going to take off the filter. And so you can see that right now I have reassigned all those samples to zone 1. You would do the same for zone 2 and zone 3. I'm just going to close this for now. But I only have this sorted for zone 1. But here's another data set where I have zone 1, 2, and 3 already coded. So we'll use this to do the implicit modeling. So once that's been domained and we've done the assigning, then we can use the vein modeling tool. So we'll see how this goes, because this computer seems to be struggling a little bit, but hopefully not for too long. Yeah, I was hoping to knock this out in half an hour, but we might be here a little bit longer, guys. All right, so we're going to be working on the Pandora or waste domain. And I'm going to do the implicit wireframing on domain 1. Let's go. Now, like all good implicit wireframes, it takes a couple of iterations to finally get to a final product that you're going to be satisfied with. So always recommend to clients that when you do set this up, pick the domain you want to do. I'm just going to hit reset so we get the default settings. And this is the samples that have been selected to be used for the wireframe for domain 1. And I'm just going to hit compute new. So this is if we're accepting all the defaults. When we compute new and the thing trundles along, the first output is never beautiful. It's a little bit nasty, but that's okay, because there is a series of tools that we can utilize to make this a lot more geologically sensible. All right. So while this computer slowly struggles along, ooh, come on, guys. Come on, Studio RM, you can do it. Excellent. Let's buy back some real estate and undock this guy because I'm not really interested in having him on the side. Fantastic. Now let's just zoom in a little bit more. So it's not the greatest, but not the worst. I'm just going to just hide this wireframe and let's just sort out a whole bunch of issues that we've got. This hole here, the sample actually ends in mineralization, which I don't particularly want. So what I'm going to do, I'm just going to click that sample and I'm just going to ignore the fact that it's ended in ore because I don't want it to snap to it because it's probably a lot longer than what I think. And then if we look back at our wireframe, there are these gigantic holes where it seems that there are no samples along, no mineralization has been detected. But if I have a look at my copper attributes, you can see there's like low mineralization, and I may have just missed that when I was doing the assessment with the compositing via ore waste. So what you can also do is you can actually add additional points. So you can use points. I've made a file previously where I'm now going to use those low mineralization areas in two areas, so in through here and also in through there. So let's say I've done those through, and if I were to hit recompute, hopefully I should see a relatively good improvement to what I have generated. Oh, no, oh, okay, so it is not happy because when we picked it, yep, and recompute. This time I've selected our points. So this time it will look a little bit better. Okay, so there's been some improvement, but still not loving everything that we're seeing. So what else can we do? Now, there's a handful of other useful tools that we can do. If I minimize edit samples and additional points, the issue we have is that I'm still getting these weird gaps. The kind of best way to control this is to use minimum thickness. So right now it's set on 0.01, and to remove below this is quite tight, and I know that this deposit is quite thick. So let's hit it. Let's set this so that is the minimum thickness is 3, and I want to expand to. The other thing that we can also look at is our boundary. So it's quite sharp on the edges how it's ended. So you can actually constrain the extension. So we could change that to 20 if we wanted to, so it doesn't go past far the last set of drill holes so aggressively. Or we can use custom strings. So a lot of our clients like to use this. Here's one that I've made earlier. So I've gone around and gone, you know what, I think the footprint or the extent of this ore body should be like so. So I'm going to reference this boundary string, and let's have a look on how this has improved the interpretation. So it should tick along. It's not looking too bad now, but I still have these weird little gaps that I'm not too much of a fan on. Let's say I've put on my geological hat and decided, you know what, I don't want that to be pinched out. If we go back to controls, what we can do, we can actually turn off the pinch out. So where it's pinching out, we can get it to not do that. And also, if I look on the sides, the edge of my deposit is quite thick. Like I'm creating a lot of volume there, which I don't think is necessarily true. So one of the things we can also do is actually reduce the boundary thickness. So right now it's maximum thickness is whatever the last set of intervals are, but I can really tighten that up if I want to. So I'm just gonna type in 10. So I'm getting rid of pinch outs and I'm tightening up my boundaries. And if I recompute one more time, let's have a look at how that's behaving. And you can see that it's getting a little bit better. It's not going too badly. I'm not mad at it. One thing I will show you, because I do think it's useful, this deposit right now is actually sitting above the topo. So you can actually use the fault tool to cut it. So I'm going to utilize this and I'm going to reference my topography. And because there are no samples above my topo, what should happen is that this should do a pretty good job at splicing it above. So I'll just run that one more time. And let's have a look at how we're going. So this is my final product now. I'm just going to turn off the topography. I'm going to close the wireframing tool. And let's just have a quick look. And it's looking all right. It's an improvement in what we had before. So now that I've done all this, obviously I've used some points and boundaries to generate this. I'm going to save all of this because you can use it again if you want to update it. So it's good habit to save early and save often. So I'll just save the draw file. I'll just quickly say yes. Cool. Yeah, that's okay. And I will save our wireframe as well. So this is currently now only being stored in the 3D viewer. Now, obviously, once this is all saved, we've got our wireframe that we can use for our estimation. And it appears that there's probably nothing else we need to do except probably Boolean the shear against the intrusive model. So we can easily do that with all our Boolean tools. They're pretty much the same across most software packages. I'm going just to use difference, and I'm going to have my domain cut across my intrusion, and I'm going to create a new wireframe called difference. Hopefully that should have run, and what should have been produced, and I'll just get rid of this. Yep. We'll remove domain. Get rid of intrusion. We'll get rid of domain. And then, so that's our final product here. So with all good wireframes that we do, once we've kind of gone to the final result, we want to verify that everything is okay. So the verification tool is in the wireframe ribbon. All you want to do is click wireframe and click OK to make sure that everything is fine. I won't run it because my computer is being really slow and time is of the essence. So effectively, this was a small demonstration of how Studio RM's geological capacity. We've just scratched the surface of our current implicit modeling tools. Hopefully, we've given you a flavor of the kind of geological modeling that can be done, the types of steps and tools we have to get our data ready. Preparation is required for the vein tool, not always required for the others. So for those ones, they should be a little bit more straightforward. Now, the last step we're going to do is compositing. So this is regarding coding the domain to the drill holes. In our case, for us, the drill holes that we have, some clients follow, the workflow that we have here, where we've coded the drill hole with the domains and then generated the wireframes from them. Other workflows other people might use is that you generate the wireframe first and then you use that to code the wireframes. If that's the case, if you're doing that, what you'll need to do is you'll need to use these tools here, so selecting wireframe or code using wireframe to code the domains into the drill hole files. Now, once we are at the stage where we have drill holes with domains, we're ready to composite. So we're going to use the composite tool back in sample analysis, and it's just the big button, which is CompDH, which is one that a lot of people would be relatively familiar with. I'm just going to hit restore in through here. And what I'm doing is I'm taking my drill holes, putting that out as comps, and I just need to make sure that I've entered my fields and parameters accordingly. So important thing with the CompDH is that in the fields for zone, we want that to reference the domain or whatever you're coding the domain as. When we specify the domain here, it means that composites cannot straddle across boundaries of the different colors, so the different composite values. So this ensures compositing happens within their own domain. In parameters, the interval that I'm going to composite to is 1.5. We have some gap handling, so max gap and comp. I don't have any gaps in my data set, so I don't need to worry about that. The minimum composite filter will filter out the output composite file based on length, so I'm going to put that as 0 so I get all the composites. With mode, you have the option of 0 and 1. So 1 is best fit and 0 is fixed length. So depending on how you want to manage your tails, choose accordingly. I'm going to go for 1, so that is best fit. So it will take the tails and kind of get close to the interval that I want, which is 1.5. If you are using Studio RM 2.0, this is new to the software. You can actually composite bottom up if you want to. So by default, this will composite top to the bottom, but we can composite top up. And for the sake of prepping the data for next week, I'm going to put in a filter, so domain greater than 0. And yes, I do want to run this, and oh, it's going a little bit wild, but that's okay. And once that's run, I should have my composite file. I'm just going to open up my composite file so that you can see that I've run a best fit. So the composite length will be as close to 1.5 as it can be, and it won't have those strange residues. So it's gone as close as it can. And these are the composites that we have generated. From our comp.dh files in through here. So we'll use this data set next week to do our EDA.